Hello, everyone. Welcome back. Good morning. Thank you for joining us again. I'm Steve.
And I'm Scott.
Together, we are Backyard Musings. Together, we are Backyard Musings. Broadcasting Apple Valley, California.
Yep, both from our humble abodes. And we are talking about a NASA topic today. So hopefully everybody that's interested in that will tune in, subscribe if you haven't subscribed. And we're grateful for that. And here we go.
Unusual radio signals from beneath Antarctica's ice continue to defy explanation, but we all know what it is. Is it another command chair from the ancients regarding Stargate? We all know that's what it is. Several years ago, scientists using a cosmic particle detector in Antarctica recorded a series of puzzling radio signals, according to an international research collaboration that includes experts from Penn State. So it must be legit. Between 2016 and 2018, NASA's Antarctic Impulsive Transient Antenna, ANITA, short for ANITA, a collection of instruments carried on high-altitude balloons over the Arctic ice, picked up strange bursts of radio energy unlike anything seen before. It could be penguins, but I'm thinking it's the chair. Now, a new study has added fresh context to these nearly decade-old findings. Would you like to know more?
Okay, the ANITA mission was designed to study distinct cosmic phenomena by detecting radio waves produced when cosmic rays strike Earth's atmospheres. However, instead of bouncing off the ice as expected, some of the detected signals appeared to originate from below the horizon. This upward direction defied current models of particle physics, and at the time raised the possibility that ANITA had uncovered new types of particles or interactions previously unknown to science, the researchers explained.
To investigate further, scientists turned to the Pierre Auger Observatory in Argentina. By examining 15 years of data on cosmic rays, the international team, including researchers from Penn State, sought to better understand the mysterious ANITA detections. Their results were recently published in the journal Physical Review Letters on March 27th, 2025.
Stephanie Weissel, associate professor of physics, astronomy, and astrophysics, who worked on the ANITA team, explained that calculations show the unusual signal would have needed to travel through thousands of kilometers of solid rock before reaching the detector. Under normal circumstances, the journey should have completely absorbed the radio waves, making the signal impossible to detect, but obviously not.
I love this, how the first thing they do is they pull out their slide rules and start calculating. This is pretty cool.
Yep, right out of their pocket protectors.
Yep. I got pens in my pocket, and they must be protected. Neutrinos, a type of particle with no charge and the smallest mass of all subatomic particles, and we've talked about like a neutrino generator, are abundant in the universe, usually emitted by high energy sources like the sun or major cosmic events like supernovas or even the Big Bang. There are neutrino signals everywhere. The problem with these particles, though, is that they are notoriously difficult to detect. Weasel explained. Why don't we just get a neutrino detector? Wouldn't that be easy?
Yeah. Maybe they should have come up with a neutrino detector before the neutrinos.
That's what I'm saying.
I mean, they could have been everywhere, and they didn't even know it.
Yeah.
So, once detected and traced to their source, these particles can reveal more about cosmic events than even the most high-powered telescopes. This is added by Weissel. As the particles can travel undisturbed and almost as fast as the speed of light. Ooh, that's pretty quick. Giving clues about cosmic events that happened light years away.
Weissel and teams of researchers around the world have been working to design and build special detectors to capture sensitive neutrino signals, even in relatively small amounts. Even one small signal from a neutrino holds a treasure trove of information, so all data has significance, she said.
ANITA is one of these detectors, and it was placed in Antarctica because there's a little chance of interference from other signals. To capture the emission signals, the balloon-borne radio detector is sent to fly over stretches of ice, capturing what are called ice showers.
The These special ice interacting neutrinos called tau neutrinos produce a secondary particle called a tau lepton that is released out of the ice and decays. The physics term referring to how the particle loses energy as it travels over space and breaks down into its constituents. This produces emissions known as air showers.
If they were visible to the naked eye, air showers might look like a sparkler waved in one direction, with sparks trailing it.
Oh, like a comet with a tail?
I was just going to see, like a comet tail.
Yeah.
So the researchers can distinguish between the two signals, ice and air showers, to determine attributes about the particle that created the signal.
These signals can then be traced back to their origin, similar to how a ball thrown at an angle will predictably bounce back at the same angle, Whistle said. The anomalous findings, though, cannot be traced back in such a manner as the angle is much sharper than existing models predict.
All right. By analyzing data collected from multiple ANITA flights and comparing it with mathematical models and extensive simulations of both regular cosmic rays and upward-going air showers, the researchers were able to filter out background noise and eliminate the possibility of other known particle-based signals.
The researchers then cross-referenced signals from other independent detectors like the Ice Cube experiment, not making that up, and the Pierre Auger Observatory to see if data from upward-going air showers similar to those found by ANITA were captured by other experiments.
Analysis revealed other detectors did not register anything that could have explained what ANITA detected, which led the researchers to describe the signal as anomalous, meaning that the particles used or causing the signals are not neutrinos. Okay, that was explained by Whistle. Back when they were first detected, theories swirled that signals did not fit within the standard picture of particle physics, and others suggested it might be a hint of dark matter. But the recent lack of observations with Ice Cube and Auger really narrow the possibilities, Whistle said.
The teams have been working on balloon projects for over a decade, Whistle explained, and added that her team is currently working on designing and building the next big detector. The new detector, called PUEO, will be larger and better at detecting neutrino signals, Whistle said, and it will hopefully shed light on what exactly the anomalous signal is. We all know what it is, Scott. We all know. It's an ancient chair.
Stargate.
There's probably a Stargate buried there too, next to the chair. You got it, Scott.
Okay.
Is that applause from our audience?
Yeah, applause. I hear it. And the only thing I can tell you is that I don't remember studying particles like this in high school physics.
No, neither.
It must have been the next level. So, but at that point, I was at my prime with physics, high school physics, Mr. Smith's class. Yeah, that's the size I got. But hey, this is cool stuff.
All right, folks. Thanks for joining us.
Take care, everyone. Thanks. See you later on this afternoon.